Okay, so like before when we did just the monomial times a binomial, now we're going to show ourselves how this works. So again, if I had just numbers, I would definitely just use GIMDOS. So 3 plus 4 is 7, and 5 plus 6 is 11, and 7 times 11 is 77. So we know that 3 plus 4 times 5 plus 6 is the same thing as 7 times 11, which is 77. By the way, not a mathematical proof. We're not quoting laws and that kind of stuff. All right, so now let's look at the other side. We're going to do the same thing we did with repeated distributive property, and we're going to take A times C, that's 3 times 5, positive times a positive. Then we're going to take A times D, all right? Positive times a positive is a positive. That's 3 times 6. Then we're going to take B times C. Again, positive times a positive is a positive. That's 4 times 5. And then finally, we're going to take, B times D. Positive times a positive is positive, so 4 times 6. So here we go. Have to do our multiplication first. That's 15. 3 times 6 is 18. 4 times 5 is 20. And then finally we have 4 times 6 is 24. All right, I'm just going to add up all of my tens first. So there's a 10, 10 is 20, 40, 60. Okay, so I got 60 and tens, and then I've got, what, a 5 and a 4 is 9. 9 and 18 is 17. So that's 10 plus 7. So I've got 60 plus 10 plus 7, or 77. You can use a calculator if you like. But as you can see, once again, it works. And once again, if it were numbers, I wouldn't use distributed property. But since one of these might be a letter, then if this was an X, I don't know what X is. So I can't tell you what 3 plus X is. I couldn't do that. I can tell you what X times 5 is, because I don't know. So if you have letters, if you have variables, then you have to use repeated distributed property. So anyway, there's our proof. It does show that it works out either way. All right, so now let's go to an example. Okay, we're going to start with 3x times 2x, 3x times 2x. Then we're going to go with, let me do that in a different color. I think we always start with red first. So let's do 3x times 2x, 3x times 2x. All right, then we did 3x times 4. Again, positive times a positive is positive. 3x times 4. Okay, and then we went to 2 times 2x. Positive times a positive is a positive, so 2 times 2x. And then finally, we did 2 times 4. Positive times positive is positive. All right, so let's start in the red. Again, this is all being multiplied, so I can put it in any order I want. I put my coefficients out front, times x. Okay, I'm going to do the same thing on the blue. How would I write that? 3 times 4 times x. My green's already where I want it. I have all my coefficients and constants out front. And then finally, I believe that was supposed to be a times in there. That's a times. Whoops. Times plus 2 times 4. All right, so we know how to do this. 3 times 2 is 6. X to the first times x to the first is x to the second. Okay. Positive. 3 times 4 is 12, and we just have an x there. Okay, then we have 2 times 2 is 4. Up there's that bell again. 4x. And then finally, the real brain buster over here, 2 times 4, which is just 8. Now, these are usually going to be in this form, something letter plus number, something letter plus number. And when they are, they'll always end up like this. You'll have a square out front, 2 of the letters in the middle, and then a number hanging off of the end, a constant hanging off of the end. So there's no other x squared, so there's nothing I can combine it with. So I've got 6x squared. But I do have a 12x and a 4x. Now, those I can combine. Those are the same base, same power. I can add those together. So a 12x plus a 4x is a 16x. And then finally, there's nothing to combine the constant with, the 8 with, so it's just plus 8. So there is the answer. That is this whole binomial simplified. And it's already in proper form because the highest degree is first. So there's a 2, there's a 1, got a constant at the end. So that's an example of how you do that. You need lots of practice. Keep practicing on these. If you have any questions, please let me know. Thank you very much.